So now let us talk about the derivative of hyperbolic function. So we know that for the trigonometric function, the derivative of sine will be cosine, the derivative of cosine will be minus sine. For the hyperbolic function, what is the derivative of hyperbolic sine? We know that the hyperbolic sine is given by exponential of x minus exponential of minus x divided by 2. So we need to find the derivative of this expression. So 1 over 2 is just a constant, just we need to find the derivative of exponential of x minus the derivative of exponential of minus x. Derivative of exponential of x will be exponential of x, derivative of exponential of minus x will be exponential of minus x multiplied by minus 1. And here we have minus, so minus with minus will be plus. So we see that the derivative of hyperbolic sine is given by exponential of x plus exponential of minus x divided by 2. So this one, remember us to the function which is cosh of x. So we conclude here the derivative of sinh x is equal cosh of x. If you do the same thing to find the derivative of cosh x, just you will take here the exponential of x plus exponential of minus x divided by 2. You have 1 over 2 is constant, so no need to differentiate. Derivative of exponential of x will be the same. Here you have the positive sign, so here will be plus. Derivative of exponential of minus x will be minus exponential of x. You have here plus and minus, so this will be negative. So if you compare exponential of x minus exponential of minus x divided by 2, this will be just the sinh of x. So we conclude that derivative of sinh will be cosh, and the derivative of cosh will be sinh without any minus. So if you remember that the derivative of cosine will be minus sine, but here for the hyperbolic function, the derivative of cosine will be, the derivative of hyperbolic cosine will be hyperbolic sine without any negative sign. Also the derivative of hyperbolic tan, first we need to rewrite the hyperbolic tan. It is hyperbolic sine divided by hyperbolic cosine. So now here we will use the quotient rule. So we'll get hyperbolic cosine multiplied by the derivative of hyperbolic sine minus the hyperbolic sine multiplied by the derivative of hyperbolic cosine divided by hyperbolic cosine square. So now here we have hyperbolic cosine will be the same. Derivative of hyperbolic sine we see from the previous, it is cosine, hyperbolic cosine. So here we have hyperbolic cosine multiplied by hyperbolic cosine will be hyperbolic cosine square minus, here we have hyperbolic sine. The derivative of hyperbolic cosine, we said it is hyperbolic sine. So hyperbolic sine multiplied by hyperbolic sine will be hyperbolic sine squared. So we have hyperbolic cosine square minus hyperbolic sine square divided by hyperbolic cos square. If you remember from this identity, we see that the hyperbolic cosine square minus the hyperbolic sine square is given by 1. So we can replace this one. We can replace hyperbolic cosine square minus hyperbolic sine square by 1. So we get 1 over hyperbolic cosine square, which is just hyperbolic sec square. So we conclude that the derivative of hyperbolic tan is given by hyperbolic sec square. So here the derivative of hyperbolic function, if u is equal g of x is a differentiable function, then the derivative of sinh is equal cosh multiplied by du over dx. Since our function is function of u, we differentiate with respect to x, so we need to multiply it by du over dx. Similarly, the derivative of hyperbolic tan is hyperbolic sec square u multiplied by du over dx. Derivative of hyperbolic sec u is equal minus hyperbolic sec u multiplied by tan, hyperbolic tan of u. Derivative of cosh of u will be sinh of u. Derivative of hyperbolic cot of u will be minus cosecant minus hyperbolic cosecant square of u multiplied du dx, and so on. So just you need to distinguish between two things. Derivative of cosine, it was minus sine, but here we have derivative of hyperbolic cosine is equal hyperbolic sine without any negative value here, or sorry, without any negative sign. For the derivative of sec is equal sec tan, whereas the derivative of hyperbolic sec, it is minus hyperbolic sec multiplied by hyperbolic tan. So you need to distinguish between these two things to not get confused between the hyperbolic function and the trigonometric function. So now let us do example 1. Differentiate y is equal hyperbolic sec multiplied by 3x minus 1 all square. Hyperbolic sec 3x minus 1 all square. This is not multiplication. This is just one function. Also we have b f of x is equal root 4 plus hyperbolic tan sec of x. So we need to differentiate these two functions. So we know that the derivative of hyperbolic sec of u is given by minus sec of u tan of u. So we need to apply this to find this derivative. So the derivative will be we said that the derivative of hyperbolic sec is given by minus hyperbolic sec multiplied by hyperbolic tan. So here we have hyperbolic sec multiplied by hyperbolic tan, and the variable or our u of x is equal 3x minus 1 all squared, and here we have also 3x minus 1 all squared. Then once you differentiate the hyperbolic sec, then you need to differentiate what is inside the bracket, 3x minus 1 all squared. So we need to multiply it by the derivative of this one. It will be 2 multiplied by 3x minus 1. Then we need to multiply by the derivative of this bracket, which is 3. So here we get minus 6 multiplied by 3x minus 1 multiplied by hyperbolic sec 3x minus 1 all squared multiplied by hyperbolic tan 3x minus 1 all squared. So these two is from the derivative of hyperbolic sec with the negative sign. This 6 multiplied by 3x minus 1 is the derivative of 3x minus 1 all squared. So 2 multiplied by 3x minus 1 multiplied by the derivative of 3x, which is 3. So that's why here we have minus 6. For b, f of x is equal root 4 plus hyperbolic tan sec of x. So first we differentiate with respect to the power, which is with respect to root. Then we go inside the root and differentiate hyperbolic tan. The derivative of hyperbolic tan, here we have, it is hyperbolic sec square. So the derivative will be, first we differentiate with respect to the power, which is half. So it will be half 4 plus hyperbolic tan sec of x. We subtract 1 from the power, so half minus 1 will be minus half. So then we differentiate inside the bracket. Derivative of 4 will be 0. Derivative of hyperbolic tan will be hyperbolic sec square 6 of x. Then we differentiate 6 of x, it will be 6. So that's why here we get 6. Then once you simplify, so half multiplied by 6 will be 3. We have here hyperbolic sec square 6 of x. This one is power negative, so you can write it like this one. So now the derivative of root 4 plus hyperbolic tan sec of x is given by 3 hyperbolic sec square 6 of x divided by root 4 plus hyperbolic tan 6 of x. Then we have example 2. Evaluate the derivative of y is equal 3x divided by 4 plus hyperbolic cosine 2 of x at x is equal to 0. So here we need to use the quotient rule. First we differentiate 3 of x and then we multiply it by this one. Minus, then we need to differentiate 4 plus hyperbolic cosine of 2x and we multiply it by 3 of x. Divide the function by 4 plus hyperbolic cosine 2 of x all square. So let us do it step by step. Derivative of 3x will be 3 multiplied by this part, which is 4 plus hyperbolic cosine 2 of x, minus derivative of this part, derivative of 4, 0. Derivative of hyperbolic cosine will be hyperbolic sine multiplied by the derivative of 2, which is multiplied by the derivative of 2x, which is 2. So here we get hyperbolic sine 2 of x multiplied by 2. Then we need to multiply it by this 3x, so this is 3x. Divided by this one is squared, so 4 plus hyperbolic cosine 2 of x all squared. So we need to evaluate this one when x is equal to 0. So we need to evaluate 4 plus hyperbolic cosine 0 multiplied by 3 minus 3 multiplied by 0 hyperbolic sine 2 multiplied by 0 multiplied by 2 divided by 4 plus hyperbolic cosine 2 of multiplied by 0 all squared. So for sinh and cosh, if you back to the first slide, we see that the hyperbolic sine of 0, so here we get exponential of 0 minus exponential of 0, so 1 minus 1 will be 0. And for the hyperbolic cosine, it will be exponential of 0, sorry, plus exponential of 0 divided by 2. So here we get 1 plus 1 divided by 2. So 2 divided by 2 will be 1. So the hyperbolic sine of 0 will be 0. The hyperbolic cosine of 0 will be 1. So let us substitute here for our function. Hyperbolic sine will be 0 and the hyperbolic cosine will be 1. So we get here 4 plus 1, which is 5. 5 multiplied by 3, 15, minus this one, x is 0, so all this will be 0. Divided by 4 plus the hyperbolic cosine will be, the value will be 1. So 4 plus 1 will be 5. 5 square will be 25. So 15 over 25 will be 3 over 5.